Question number 12. A small ring of mass 0.024 kg is threaded on a fixed rough horizontal rod. Okay, so that means this weight would be in this direction and its value is going to be 0.24 newtons since weight is equals to mass times 10. A light inextensible string is attached to the ring and the string is pulled with a force of 0.195 Newton at an angle of 1 with the horizontal. It's probably going to be theta is in an angle of theta degree with the horizontal and sine theta is equals to 5 over 3. Okay, if sine theta is equals to 5 by 13, then this should also give us the value of cos theta. We're going to make a right angle. This would be 5, this would be 13 from so. And now we apply Pythagoras theorem here, 13 square minus 5 square, that would give us 12. So cos theta is equals to 12 over 13. When the angle theta degree is below the horizontal, the ring is in equilibrium. That means it's not moving. That means the right forces would be equals to the left forces and the up forces would be equals to the down forces. Find the coefficient of friction between the ring and the rod. Okay, since there's a pull in this direction, friction would be in this direction, and we have to find the coefficient of friction, so we can directly use the formula F is equals to mu R. So I'm writing mu R here. Okay, then there's a weight downwards. Now there'll be two components of this 0.195 Newton force, one in this direction, which would be the cos component, which would be 0.195 cos theta, and this one would be the sine component, which I'm going to instead draw here. So this sine component can be drawn here, and this would be 0.195 sine theta, and this one is 0.195 cos theta. Okay, now since the system is in equilibrium, we're going to equate the forces. So the force on the left, which is equals to mu R, equals force on the right, which is 0.195 cos theta. Okay, let's substitute the values. We need mu and R would be, R is in this direction. I forgot to plot R earlier. R is the normal contact force. It's going to be in this direction and it is opposite to these two forces. So R is equals to 0.195 sine theta plus 0.24. So instead of R, I'm writing the sum of these two forces equals to 0.195 cos theta. Okay, now let's substitute the values of sine theta and cos theta. Okay, sine theta is 5 upon 13. So replace this with 5 upon 13. And this is 12 over 13. Okay, now you make mu the subject. Mu would be equals to fraction, numerator is 0.195 times 12 over 13. Denominator is 0.195, 5 by 13 plus 0.24. Let's see what we get. 0.195 times 12 by 13 in the numerator, and the denominator is 0.195 times 15 by 5 by 13 plus 0.24. I get exactly 4 by 7. So mu equals 4 by 7. Okay. Find the acceleration of the ring. Okay, for acceleration, acha, before that, it says that when the ring is theta degree above the horizontal, the ring moves. Find the acceleration of the ring. Okay, so now in this setup, the ring is moving, which means we're going to have again a forward force, which would be a component of friction, which would be 0.195. This would be the cos component. This is the opposite component, which is the sine component, but we're going to draw it here. Okay. And since the movement will be in this direction, we will have friction backwards, mu r. And then we have a normal contact force in this direction and a weight in this direction, 0.24. Okay. Now we're going to use the formula forward force is equals to forward force minus backward force is equals to ma, which is Newton's second law. Forward force minus backward force is equals to mass times acceleration. Forward force is just one force, 0.195 cos theta, minus we have one backward force as well, which is the friction mu r, okay, is equals to mass, which is 0.024 times acceleration. Okay, now we know these values. 0.195 cos theta was 12 by 13 found earlier, minus mu is 4 by 7. R was found earlier as well. This was R, but R is going to change now. Hold on. Now we will write upward forces. There are two upward forces is equals to downward force. So we have R plus 0.195 sine theta equals 2.4, 0.24. Okay, which means R equals 0.24 minus 0.195 sine theta. And we already know the value of sine theta. Okay, so instead of R, I'm writing 0.24 minus 0.195 sine theta. And all of this divided by 0.024 is equals to acceleration. And instead of sine theta, we're going to write 5 upon 30. Instead of this, we can write 5 by 30. Let's enter all of this in the calculator times 5 by 30. Okay, so we have 0.195 times 12 by 13 minus fraction 4 by 7 times bracket 0.24 minus 0.195 times 5 by 13 and bracket close divided by 0.024, which gives me 3.5714. So acceleration would be 3.5714 meters per second square.